All right, it's good to see everybody today. We should be able to finish up the main set of notes. We'll finish with the quiz today over the homework we turned in yesterday. It's not covering the material that we're going to be talking about today or that we started on yesterday. But the test coming up on Monday will have the 6 trig functions on there, right triangle, trigonometry. So we'll get the opportunity to go ahead and review that. Tomorrow, Miss Stern is going to go ahead and work some problems with you guys as well, start to get a little more active in the classroom. And then on Friday, I'll have an exit ticket after we talk about the homework for you guys to work on. In fact, this one right here, the new homework assignment, that's due on Friday. Okay, that'll be due on Friday. We'll see if we can get you some time in class to go ahead and start working on that. That way you don't have anything written for the weekend except to go ahead and look over your notes for the test. But remember, what can you use on the test? You can use your notes. Okay, so anything you have, homework, notes, all that's good. Okay. So let's see, this focus activity is made up of 2 more problems that were the most missed on that district assessment. We took Friday before last, about a week and a half ago. This was number 4. Given the function f of x shown below, determine the algebraic representation for f of x, f inverse, and any domain restrictions applicable on f of x when determining the inverse function. Okay, well, why don't we go ahead and start here? This is a quadratic. But what would the equation of that quadratic be? How has he been shifted? To the left, how far? Okay, so to the left 3 and up 2. Now remember, with the x's, we always have to take the opposite, so it'd be x plus 3 squared, and then, of course, the plus 2. So looking at my answers, does that help me eliminate anything? Okay, g is out, because the minus 3 would actually shift it 3 right. Okay, so that's 1 down. Okay. Now, talking about inverses, we got in the habit of applying a horizontal line test to these guys. What were we looking for? Check if it's 1-to-1. Okay. So if I put a horizontal line through this guy, is he 1-to-1? He is not 1-to-1. Now remember, this tells me if the inverse is going to be a function or not. If my graph is 1-to-1, guaranteed the inverse is a function. I don't have to do a thing, find the inverse and move on. If my graph is not 1-to-1, as this is right here, we have to go ahead and restrict him so that we ensure that my inverse is going to be a function. So are there any answers that I can eliminate based on that? Yeah, F is gone because we just said he's not 1-to-1, so we have to restrict him in some way. Okay, so right there, we've already got it down to a 1 and 2 shot, 50-50. Okay, it's either H or J. Well, let's take a look at the restrictions. This one says I'm going to restrict it to everything greater than or equal to -3, and this one says I'm going to restrict it everything greater than or equal to 2. Well, let me go ahead and draw these vertical lines here. There's -3, and there's 2. Imagine that's a straight line. Okay, so which one's going to make more sense to cut half the graph off? H. Okay, if I go ahead and say he only exists bigger than or equal to -3, well, that means I'm cutting him off there, so now he's going to be 1-to-1. He passes the horizontal line test. So without even having to find the inverse, I know the answer's got to be H. Okay. Now, let's say I did want to go ahead and find the inverse. How would I do that? There's something I do with X and Y. I switch them. Okay. So if I have y equals the quantity x plus 3 squared plus 2, then I would say x equals quantity y plus 3 squared plus 2. Okay. So let's see here. Let me go ahead and raise this up. Okay, so what's first? Okay, let's subtract the 2. All right, so x minus 2 is equal to y plus 3 squared. Now we got to take the square root, okay, because we want to get rid of that square. So the square root of x minus 2 is equal to y plus 3. And then I heard someone say subtract. Minus 3, minus 3. Okay, so it looks like we have the square root of x minus 2 minus 3, and that is the inverse they're showing in the answer we chose. And of course, our last thing, because this guy was a function, we can go ahead and replace the y with the f inverse. Okay. All right. Do you guys remember this problem? Does anybody remember what they chose? I haven't looked at the data in a week and a half, so I don't remember. Okay. No? Okay. Well, let's take a look at number 2. This one was on compositions. This was number 10 on the district assessment. Retail salesperson earns a 4% commission for sales over $750 per week, plus a weekly salary of $480. Assuming enough merchandise is sold to earn commission, which of the following sets of functions and composite function represents the weekly commission earned? Okay. Well, there's actually one value here that we don't need. What is it? Yeah, now it's important to the salesperson because that's what they're earning per week, but we don't need it in order to answer the problem. It's just extra information, and they'll sometimes do that. So look at all your answers. The F function is either 750 minus X or X minus 750, where X is the amount in sales that you make per week. Now, you're only going to earn that 4% if you sell what? Over 750. It would have to be X minus 750. So the two answers, F and H, where they have 750 minus X, those are out. Okay. And also think, what's 4% as a decimal? 0.04, right? You move it 2 spaces to the left. Well, that would also have told us to get rid of H, because that means they'd be earning a 40% interest on that particular value, but we'd already gotten rid of it. So it's either G or J. And the only difference here is the composition. Now, what would make more sense? Would I find the amount of money, the difference, and then apply the percentage? Or would I take the percentage and then find the difference? Yeah, you'd have to find the amount of money that you're going to take the percentage of first. So you'd have to take F and plug it into G. Okay. All right. Does that make sense? Okay. Any questions? Okay. All right, so we now have 4 focus activities. We are turning them in on Tuesday, the day after the test. My goal is to try and get one more, bless you, either on or before that. We'll see if it happens. If not, I mean, we only have 4. If we can, great. Okay, so we'll see how that plays out. All right, so go ahead and put that to the side. And let's wrap up our current lesson. Okay, so we've been talking about trig functions here. Okay, so if you happen to have lost or misplaced the notes, I've got those right over there in the filing cabinet by Adolfo. Okay, so let's do a quick review. This is as far as we got, right? I think we set up this problem, but we didn't finish it. Okay, cool. All right, so we already did find that the base here was the square root of 11, but let's go ahead and do a quick review. My sine, cosine, and tangent. Remember, SOHCAHTOA. Okay, the letters tell you not only the trig function, but the side lengths, the ratio that we're going to go ahead and take. We have adjacent, opposite, and hypotenuse. What was sine? Okay, sine is always opposite over the hypotenuse. What about cosine? That's the adjacent over the hypotenuse. What about tangent? Opposite over adjacent. Okay. Okay, so those were the side ratios. Now, when you evaluate a trig function, if I were to take, any of these 6 here and substitute it in an angle measure, whether it's degrees or radians, the answer is always going to be the side ratio of these triangles here. Okay, any of those 3. Now, I also introduced you to the reciprocals. So the reciprocal of sine is cosecant, CSC. He is the hypotenuse over the opposite. So cosecant, we abbreviate CSC. Okay. What about secant? That's hypotenuse over adjacent. He's the reciprocal of cosine. So adjacent. We just said it, and I was writing it wrong. Hypotenuse over adjacent. And our last one here, cotangent, is the reciprocal of tangent. So he is adjacent over the opposite. Well, for this problem here, I was able to create the right triangle, use the Pythagorean theorem based on the one ratio given. Remember, sine is the opposite over hypotenuse. Okay. Well, they've already given me 4a. I know that's 5/6. Without doing anything, what other trig function do I immediately know? Cosecant. If sine is 5/6, cosecant has to be 6/5. That's exactly right. Okay. Now, for the rest of them, okay, we've got these labeled here. Now, square root of 11, the only side left would be the adjacent. So for cosine, I want the adjacent over the hypotenuse. So you're right. Square root of 11 over 6. Now, I remember some word we were talking about yesterday, rationalize. What's that?
So the top number, the square root can't be on the bottom.
There you go. If we have a radical in the denominator, rationalizing means we're going to rewrite it. We're going to remove it. So this one's fine. We don't have to do a thing. What about tangent of theta? Okay, so the opposite 5 over the square root of 11. So this one I am going to have to rationalize. So I'm going to multiply square root by itself, right? But I'm also going to multiply the numerator by the exact same thing. So what's that end up being? 5 square roots of 11 over 11. When you multiply a square root by itself, those radicals just cancel out. Or you can just say square root of 121, which is 11. Okay, and our last ones here, 4e and 4f. Let's see. Now for secant, I need the hypotenuse over the adjacent. All right, so whether you go to the diagram or you just go to 4b, the reciprocal, we're just going to go ahead and flip it. So I've got 6 over the square root of 11, the hypotenuse over the adjacent. So just like before, I need to go ahead and rationalize. I'm sorry, second? Oh yeah, absolutely. It's going to do the exact same thing. Yeah, so if you want to go ahead and give me the final answer, I'm fine with that. That's absolutely fine. 6 square root of 11 over 11. That's perfect. Yes. Okay. In fact, can anybody tell me what f would end up being? We want the adjacent over the opposite. Square root of 11 over 5. If you go straight to the diagram, it'll give me that. Does anybody want me to take the answer for tangent, flip it, and show you that you're going to end up with that? No? You do? Okay. Let's do it. So if I were to take 5 square root of 11 over 11, okay. Whoop, let me flip it. So 11 over 5 square root of 11. And we're going to rationalize just like we were doing. Square root of 11, square root of 11. Okay. So that would be 11 times the square root of 11 over. Now, the radicals are going to cancel, so this would be 5 times 11, right? But I'm going to go ahead and leave it as is so I can just cancel out those 11s. Otherwise, I still would simplify if you multiplied. But again, square root of 11 over 5 is exactly what we just got. Okay, good. All right. Well, now let's go ahead and take a look at some of these on the calculator. Okay. Now, all of these are in degrees, so you want to make sure your calculator is what? In degrees. Like, in fact, if I go to my home screen right here, okay, and it's not letting me do that. Sometimes it'll work and sometimes it won't. Okay, so, oop, that's not what I meant. Let's go ahead and delete that. I believe there's another one on there. There we go. Document B. So you notice at the top, mine already says DEG. It's in degrees. But if you do need to change it from your home screen, remember you'll go to Settings, and then Document Settings, and then right here the second one. So you'll want it to say degree. If it doesn't, you can just use the drop-down menu, change it. But then always make sure to click Make Default. Make Default. Don't just click OK. All right. All right, well, let's take a look at the first one. I don't remember what that was off the top of my head. I think it was a cosine, but I could be wrong. Is it a cosine? Cosine of what? 30 degrees. That's okay. So all I'm going to do is come over here on your calculator to the left of 7, right below the blue control button. There's a button that says trig. When you click it, All 6 of your trig functions are going to come up. Now below them, those are the inverse trig functions. I'll be showing you those later. So I'm just going to choose cosine, and I'm going to go ahead and plug in 30. And there we go. That's it. That's all there is to it. There's no tricks. But now I do want to go ahead and make a connection. Genevieve? Yes, we're going to talk about that. Because in that case, you'd be dividing by 0. Now, let's think about this. Yesterday, we went through the special right triangles, right? The 45, 45, 90, and the 30, 60, 90. Okay, now remember, cosine of 30, we got this. Well, let me revisit that problem. Was it this one? Nope, that is 60. Look at this one. When we set up the triangle, by hand, we got cosine of 30 was the square root of 3 over 2, right? Well, let me come back over here to the calculator, control divide. Okay, I'm going to type in the square root of 3 divided by 2, the answer we got when we did it by hand. Okay, because I want you to notice when you evaluate a trig function using an angle measure like I am here, you know, that decimal means something. Okay, you're going to get the ratio of the side lengths of a triangle. So whatever the adjacent length was divided by the hypotenuse, that's what I'm getting. The same is going to be true for all the rest of these. Okay. So let's try the next one. Sine of 45. So I'm going to come on over here. The trig button right next to 7. So sin, I want the sine of 45 degrees. I'm going to get 0.7071. Okay. Uh-huh. Yeah, typically I'll go ahead and tell you probably to the nearest hundredth or the nearest thousandth. In this case, I'd say probably thousandth, so 3 decimal places. So this one would be 0.866, and the other one would be 0.707. So if you do go ahead and look earlier in your notes, when we evaluated sine of 45 degrees, I'll just go ahead and show you one more of these. Okay, we ended up with the square root of 2 divided by 2. That was the answer when we did it by hand, one of the first things we did. Well, when I push enter, again, that's what it represents. See, in order to get that square root of 2 over 2, we made a fraction with the opposite side over the hypotenuse. Okay. So that's exactly what evaluating a trig function is going to give me. It's the side lengths in a ratio from a right triangle. All right. Now, let's look at C. Genevieve said there was a problem with this one. Tangent of 90 degrees. Okay, tangent of 90. And she's absolutely right. As soon as I push enter, that means undefined. Well, you get undefined when you're dividing by what? 0. Okay, so here at 90 degrees, remember that's a quadrantal. So a triangle isn't actually formed there. You're going to have a length of 0. Now, when we talk about the unit circle, it's going to make a lot more sense why that is. Okay, but here, because if you're just going straight up, there is no right triangle created. So in this case, is it the opposite or the adjacent side? Well, think about it. What is tangent? It's what over what? It's opposite over adjacent. We got undefined because I can't divide by 0. So it has to be the adjacent side that doesn't technically exist. Okay. Sine of 15. That's not even an angle that we came across yet. So let me get out of here, document B. I love it. I don't know why sometimes it'll go ahead and start putting those dots on there. And other times it'll allow me to, but here we go. Let me get rid of these dots real quick. I think there was another one. There we go. So what do we have? Sine of 15 degrees. So sine of 15. Okay. Now remember, what was sine's ratio? It was what over what? Opposite over hypotenuse, right? So whatever triangle I'm talking about, if I have an angle that's 15 degrees, whatever the length of the side opposite 15 divided by the length of the hypotenuse should be giving me that. All right. And I got another couple, cosecant of 45. So CSC, 45. So 1.41, okay. And that one, again, you can check earlier in the notes because we did work a cosecant to 45. And cotangent of 45. Does anybody remember what tangent of 45 was? Uh-huh. If we're looking back in our notes, the tangent of 45 degrees. It was 1, right? Now remember, cotangent's the reciprocal. So what's the reciprocal of 1? 1. So we should be getting the exact same thing. 1 over 1 is still 1. Okay. Good, 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 good. All right. Well, we're almost done. We only have these 2 problems and we are finished. Okay, so a couple of word problems. This one says a right triangle with a hypotenuse of 8 includes a 36-degree angle. Find the lengths of the other 2 sides and the measures of the other 2 angles. Well, there's not 2 angles to find because we know it's a right triangle. And I would always suggest if there's not a picture, go ahead and draw one. Okay. So we're given one angle is 36 degrees. So I'll just go ahead and put that right here. So really, we're only trying to find the one missing angle, not 2. So I don't know why it says that. Okay. It's not my resource. Anyways. Okay. And we also know that the hypotenuse is 8. All right. Well, all we got to do, and a lot of times you'll see these problems where it just says solve the triangle. Well, all that means is find all the missing angles, find all the missing side lengths. Okay. So let's see here. Let's go ahead and do this first. Now, if I add all 3 angles, I should get 180, right? Well, because one of these is 90, that's half of it. So all I really have to do is take 36 and subtract it from what? From 90. So what is 90 minus 36? 54. So I know this missing angle is 54 degrees. That's easy enough. Or if you want to take 180 minus 90 minus 36, it's going to give you the same result. So let's say that the height here is x. All right. And you can use whatever angle you want. Do we want the 54 or the 36? Let's go with 36. Okay. Now, because I've chosen 36, what is x with respect to that? That's the opposite. And we already know 8 is the hypotenuse. So let's think about what we've been discussing. What trig function uses an opposite and a hypotenuse? Sin. Okay. Sine. Sine. Yes. There we go. That's okay. So sine. So I would say sine of 36 degrees is equal to the opposite x over 8. But now we actually have a choice. We don't have to go with sine if we don't want to. What's its reciprocal? Cosecant. I could easily solve cosecant of 36 degrees, but remember that's the hypotenuse over the opposite, the reciprocal of what I set up there. Either one of these will give you the exact same answer. Okay. Now, personally, I would encourage you to go ahead and set up a trig function where your unknown, what you're trying to find, is on top. Because check it out. All I need to do to solve for it is just multiply both sides by the denominator, because those are going to cancel. Okay. So all I need is 8 sine of 36. Okay. So let's see here. 8 sine of 36. So 8 times the sine of 36. So the height of the triangle should be 4.7. About 4.7 units, whatever that measurement is. Okay. Is everybody okay with how I got that? Okay. So I'm going to replace the x with 4.7. Now, we could go ahead and set up another trig function because I already used x. Let's go ahead and say that's y. And why not? Anyway, y. Yeah. So we could go ahead and set up another trig function. Okay. We could use 36 and we could use 54. But because we're dealing with a right triangle, what could we actually do? Yeah. So if you don't want to set up another trig function, you could just go ahead and use the Pythagorean theorem. That would be perfectly fine. What would you guys like to do? Pythagorean or another trig function? Another trig function? Okay. So do we want to stick with 36 or do we want to go with 54? Let's stick with 36. So y would be the adjacent, right? Now, I've got the opposite and I've got the hypotenuse. What trig function do you want to use? What's that? You want to use cosine? Okay. So cosine of 36 degrees, now what's cosine's ratio? It's what over what? It's always adjacent over hypotenuse. So here it would be y over 8. But couldn't I have easily used secant of 36? Because they're reciprocal, so that would have given me 8 over y. But he chose a very good one, because now all I got to do is multiply by 8. So somebody help me out with that. Plug that in your calculator. What do you get? About 6.5? Okay. And there you go. This is just right triangle trig. Okay. All right. How we doing? Okay. All right. So I'll tell you what. I'm going to go ahead and stop there. I can go ahead and get that last problem tomorrow. That's not an issue. But I do want to go ahead and take 30 seconds real fast. Kind of remind you of a few things. Coterminal. If I could write today, that'd be great. Coterminal angles, you're going to be asked about this on your quiz. They're angles that have different measures, but that have what? What do we call that part that stops after the rotation? Or no, the initial is where it starts. The terminal is where it stops. So they have different measures, but the same terminal side. Okay, so if I were to give you something like, 30 degrees, and I ask you, I want one positive and one negative coterminal angle, what do? Add 360, and then subtract 360. Okay, so plus 360, minus 360, and you'll have your calculator to help you out. Okay, if I give it to you in radians, if I were to give you something like, I don't know, pi over 3, what would I add and subtract from it? 2 pi. Remember, 1 revolution in radians is 2 pi. So I would add 2 pi, pi over 3 minus 2 pi. And, I would get some answers there. You just have to get a common denominator. Okay. What does it mean, reference angles? It's the angle created between the terminal side, where it stops, and the closest x-axis. Yes. Okay. If it's on the x-axis, then it would be 0.
Or like which one? So like say it was like on the y, like but it's like straight up on the y.
Now, if it's straight up on the y, then it would just be 90. Because by definition, it's always going to be between the terminal side and the closest x-axis. But here, really doesn't matter what x you choose. Reference angle is always positive. Yes. Okay. Do we remember the keystrokes for DMS in the calculator? Okay. If you're in the calculator and you want to change a degrees, minutes, seconds to decimal degree, okay. I think it was Brandon, you told me about this one, right? If you go ahead and just hit this button right here between 9 and the catalog, the second row, the second icon right here, is just a fill in the blank. You just go ahead and fill it in, push enter, you got your decimal. Okay. Now, if you wanted to go the other direction, if you wanted to change the decimal to DMS, well, then you're going to go to the catalog button right next to it. Under the first tab, there's your DMS. Okay. The only other thing you're going to see on the quiz, I'm going to ask you a couple of times, I'm going to give you a degree measure and say, okay, convert this to radians. And then I'm going to give you a radian measure and say, convert it to degrees. So how do I take a radian and convert it to degrees? Times it by 180 over pi if I want degrees. What am I going to multiply by if I want radians? Pi over 180. And that's rad. Radians. Okay, let me go ahead and pass out your quiz.
So like on the degree stuff, you put like pi.
Yeah, so if your measure has pi, you'll know instinctively you want to multiply it by 180 over pi, so those pi's cancel. Okay. Okay, so here we go. hang on to it when you're done because there is a bonus question. We're going to go Marvel today, specifically Thor. I've already asked a question about his hammer. Asked a question. His hair. What conditioner he uses. That's interesting. What kind of conditioner does Thor use? Head and Shoulders. Did you never get a second chance to make a first impression? Is that still their tagline? I don't know. Anyways, y'all go ahead. Okay. I'll let you go to it.